8. And that's up incline. Up the incline. Okay. Okay, so that's good enough. That's one's for C, that completes C. Part D said, what is the maximum mass that you can have? So let's go back to this side here. What is maximum mass that you can have so that the system moves down? In other words, if you have this mass is too low, this thing is going to beat that thing, even if there's friction, right? So what's going to happen is when this thing is too low, this thing is going to tend to go down. So you have 39.2 sine of 35. Then you have t. Which direction is the friction going to be this time when this thing is too low? Now the friction is going to say, I don't want the system accelerating down the incline. Right? Friction is always fighting against the tendency of the system to move. So the friction is going to be up the incline. Okay? And when all of these are equal, and if this thing is even less than that mass, then the system moves down. You see? So mg equals t. In a way, the setup is going to look like this. I'm going to set mg equals to t. Then I'm going to set the 39.2 sine 35 equals to t plus 0.4. And then the n is still the same. And then the t here, I substitute the mg over here. And then I take this to the other side. And then this one here. So that's going to be 8, 36, 3, 12, 15 cosine of 35. So this will tell you the maximum mass that you can have on the hanger. And the answer should probably is going to be something quite small, maybe 1 pound or 1 kilogram or something. 0.98. Now it predicted pretty close. Okay, so if you have anything less than 0.98 kilograms on the hanger, then it's going to accelerate down the incline. Okay, and what else here? Oh, then now we could go back to part B and answer the other part of the other half. If I had 1 kilogram more or less than what is needed for equilibrium, that would be what? You needed 2.29 for equilibrium. So if m equals 1.29 kilogram, that's 1 kilogram less than the equilibrium, the system would still not move, right? So 1 kilogram, so think of the equilibrium as sort of like in the middle. 1 kilogram more, it didn't move. 1 kilogram less, it didn't move. Okay? So it's kind of like the, think of like the number line. You had 2.29 kilogram, 3.29, it didn't move. 1.29, it didn't move. You needed 0.98. Anything less than 0.98, it would move. And then 3.29, it still didn't move. And then what did you need to move the other direction? 3.6. So you need at least 3.6 or above, or you need 0.98 or below. So you see what it's doing is the friction is giving you a cushion. It's giving you a cushion of magnitudes, of numbers. You can have a cushion of numbers, a range of numbers there where you can put some different masses and the system is still not moving. You're going to see the same effect is going to happen in just a little bit as we start chapter 6. The same effect is going to happen. The friction is going to cause that same kind of cushion effect in chapter 6. Okay, so if m is 1.29, it's not going to move. And what's the value of Fs going to be? Well, it's going to be, this time you're going to have 39.2 sine 35 is going to equal this time the friction force is going to help the hanging mass. It's going to be up the incline, right? 39.2 sine 35 is going to equal, this one is going to be, what is it? 1 kilogram less, right? 1.29 times 9.8 plus Fs. So see the Fs went over to the other side because the friction is now going to help the hanging mass. The picture is going to look like this. You have 1.29. You have 1.29. And now, since the mass is too little, friction is up the incline, and to solve for it, you solve that way. And you get a number there, some number up the incline. It's probably not going to be 9.76 necessarily. 9.84 newtons up the incline. Okay, and now we're pretty much towards the end here. And going back to part D, if you had 1 kilogram less than that, and max, well, that would pretty much be like having nothing there, right? Because I wanted to give you the whole range. 1 kilogram more than this, 4.6. 1 kilogram less than what it takes to move, well, that would bring us down to 0, right? So 0.98, 1.29, 2.29. So this range is not moving. Down to this, it's not going to move. Up to that, it's not going to move. 4.6, and it's going to move, of course. So if you had 0, what's going to happen? Well, pretty much this thing will move down. What is its acceleration going to be? Well, it's going to move down. The friction is going to be up the incline. The tension in the rope is going to be 0, right? So if you have nothing there, it's basically similar to cutting it. You cut it, you have nothing, this thing accelerates down, so you just have 39.2 sine 35 minus mu kn, right? So 0.2 times n equals ma. That's if the mass is 0 kilogram. That's the least you can have. It's equivalent to cutting the string and letting the thing just slide down with presence of friction.